I really appreciate it. So my name is Scott. I work for a company called WePay. We're an API-based payments company similar to a Stripe. We do payments for people like Constant Contact, Meetup.com, and basically any crowdfunding site we're used. So my title is Why Your API Product Will Fail. As you might not know, if you like to get your talk unselected and you want people to show up to it, you should have something really clickbaity. And that's what this is. So what the title probably should be is something more along the lines of how to build API tooling that doesn't suck. My name is Scott. Some people confuse me for Taylor Swift. Sorry if that was a confusion. I'm coming in. I was also told that if I included a photo of her, people wouldn't be mean to me. So today's agenda is, what does good API tooling look like? And how do I build it in a scalable way? How do I build it in a way where every time I launch a new version of my API, I'm not freaking out? Okay, so let's start with, what is API tooling? But before we get there, how many people have ever used an API before? Most people, pretty much everyone. How many people have used a API that sucked? Okay. How many ever used a API that did things that the documentation said that it didn't do? Yeah, a lot of people. So what API tooling is meant to do, when it's built well, is prevent things like that from happening. It's to give the consumers, that's us, the chance to use the API in the way that it was designed to be used. Now remember that every time you use a API, there was a developer, just like us, perhaps someone even in this room, who decided to write the docs for that, or wrote the actual API. So consider that, not that like you should be sympathetic, but that when you're doing it yourself, you don't have to do those same things. So API tooling is essentially two things. It's documentation and it's the actual API clients. Some people call them SDKs, other people call them wrappers. Whatever you want to call them, they are the way that someone interacts with your API. Now, if they want to use a curl client, whatever, but most people offer some sort of client library. So that documentation can be further broken down into tutorials, the actual reference docs, and the explanation and use cases of those API calls. So we'll start with the tutorials. How many people have ever, when they started using a API, probably didn't jump into the reference docs? You probably said, okay, what is the smallest thing that I can actually do with this API? Give me a how-to guide, if you will. So what this how-to guide needs to do is it needs to tell you what you're actually doing. You've never used this API before, then you probably don't know. You're probably going to need some detailed steps that even perhaps the most junior person on your team would be able to follow. And also, I don't know about you, but I don't actually really like doing work. I would really just like to copy and paste stuff. Ideally not off Stack and Overflow. Ideally like from your docs themselves. I don't really want to have to Google it, but make it easy for me. Make it easy for me to just sort of like copy paste, get going, because I don't really want to do work. I don't know. I don't know about you. So here's an example of what a tutorial looks like. You should have some sort of like explanation of what you're doing. You should have some sort of example use case for how this might be used. And then, before you actually just create a large tutorial with lots of steps and copy and paste, you should actually probably tell the person from like a high level, this is what we're actually doing. Because likelihood is, if I probably don't know, I'm accessing your page, you might have a good title on it, you might not. Just tell me, okay, like before I get started, like halfway through, oh wait, this isn't actually what I wanted to do. Because most tutorials, they're very text heavy. Don't make me read. So, with each step, don't just include the code. Include some sort of like, this is what you're actually doing in this code. While it should be obvious, your code should be like at least decent, it doesn't, it might not be that obvious to someone who's consuming it. So beyond tutorials, once you're actually using an app, the likelihood is you're going to need to do something a little bit different. Something that maybe the tutorial writer didn't come up with. And that's when we're going to talk about reference docs. So these are the docs where you see all the calls and everything that an API does. So the simplest API call is, I'm going to send you an ID, and you're going to send me an object back. It's a very simple get. So in this get, you're going to want to see, okay, so what's the parameters that I actually need to pass? Is it required? Do I need them? It might not just be one, it might be a few. What is the type of that? And then give me an example. Well, this is, this one here is really basic. More complex stuff, that stuff is actually really needed. And then once that stuff is actually returned, you need to tell me what is it that you actually just sent me. I don't know your app, I don't know the object structure. Actually break down for me what each of those parameters is and how I'm supposed to use it. And in addition to that, it's really nice when you give me like a JSON example to work with. If I don't have some sort of example data structure that I can copy and paste into my code and actually start playing with, it might, while like you're like, well, you can just make a call and then you can play with that. Not every call to your API can I immediately make. I might need some actual data in there first. So let me figure out how I'm supposed to play with it before I actually have to make a call. So in your reference docs, you need to make sure that every resource is well documented. It's okay to visually duplicate things in docs, because one of the worst things you can do is give me like a bunch of links to other pages, and to actually understand what your what an API call is doing, you're making me jump around. You're making me access 3, 4, 5 different files to do one thing, and that's no fun. Also, the requests and the response bodies, make sure that I can copy and paste those. Make sure that I can actually see what those are. Don't hide those from me. Don't make me make calls just to see what your API does. And for each parameter in those, make sure that those are well documented. Otherwise, you're going to have people emailing your support team asking, okay, what does this parameter do? It's not consistent. What's the problem? So explain what each of those are and how to use them. Now, to actually build these sorts of docs, you need to first figure out, you first need to know what your API actually does. So how many people here have some sort of spec that describes their entire API? Every resource. A few people. Most people, when they build an API, for the first time, they don't think, oh, maybe I should have a spec for this. So this leads to problems because you don't have a single point of truth. There's not one document that tells you what your API does. Now, when you make code changes, your API changes, and that's okay. But your API code cannot be the single point of truth. You need to have some other document or series of documents that describe what your API does. I shouldn't log into go and look at your SDK, see one implementation, look at your docs, see something else. They should all be exactly the same. And if you don't have a single spec that describes what all of those things are supposed to be doing, it's going to be very hard to maintain. Otherwise, you're going to be updating 3 different things every time your API changes. So there's a few different options for how you might actually write a spec. There's JSON schema, there's Swagger, there's RAML, there's API and a blueprint, and they all have different reasons why you might want to use them. So RAML, which is becoming popular, it's backed by a company called MuleSoft. Their API spec is basically just RAML. in its own way with these / resources. And the nice thing about Ramble is that it's very flexible. If you use something like JSON schema, it's going to be more prescriptive. Ramble will let you pretty much do whatever you want. You can document any API regardless of how it's structured, which is really nice when you have an existing API that you need to document, that you didn't create a spec for and don't really know how it runs. JSON schema, this was created or was used heavily by the Heroku team. They built a lot of tools to actually build these. The only problem with JSON schema is that it's very prescriptive. So if your API doesn't do the things that JSON schema thinks that it should do, then you can't really document it. But if you're creating a new API from scratch, it might be a good option for you. Swagger, most people know Swagger from the UI tools. Swagger is a great option. They have some great tools built. It's also one of the older spec languages out there. It was really one of the first ones that people started using, and they've done a nice job. The only downsides, it's very verbose. There's a lot of different parameters you have to add to it. On the other side, you have things like API and Blueprint. On the left-hand side there is what you enter, and on the right-hand side is what that generates. The right-hand side is the JSON schema representation of the blueprint on the left. While this might be okay, it makes it hard to override things, and it also just creates this very sort of like magical land. Also, like it's a giant setup. So you have these spec languages, and now you need to actually write one. So there's two different extremes of how you might write a spec. You can either auto-generate it on the one hand. On the other hand, you could write it by hand. Now, it's unlikely that you want to sit down and actually write your entire spec out. That's going to take a long time, and it's also going to just be really monotonous. Because likelihood you're going to look at your docs, and you're going to start like writing some stuff, and you're going to look at your code, see if your docs were right. And the whole exercise of that is pretty challenging. Now, if you want it all auto documented, well, that's okay. If you've ever seen Java docs, that's what those are, and they lack, what I call a human element to them. They are what you decided to include at a develop time, not when someone actually needs to use it. So the compromise is to generate a spec that is partially that is either partially generated by the code, or it's something where you have tools that help you write it. So there's two mindsets to this. The first is a partially code-generated spec, and what this is you build a tool that actually parses your code and gives you a spec from it. And then when you want to add things like lines for documentation, it just leaves those blank and handles the merge between. There's a couple pre-built tools that actually do that. If you use Grape or Rails serializers, there's a couple that can just read that. This is really easy when you're already writing your API with a tool that is prescriptive. That gives you a set way of writing your API. If you're not doing that, if you're not using some sort of prescriptive tool, it's going to be a lot harder to actually parse your code to generate that spec. So on the other hand, you have these hand-built specs, which are ones where you're actually writing out the spec. But instead of just writing it by hand every time, you can build a lot of tools that will do that for you. So with Rails, similar to like Rails New, you can do things like Resource New. And you can build a generator. There's a lot that are out there that will just generate a sample spec for you that you then need to fill in. This makes it easier to use. You can do a validation that way, just to make it easier for you to write it by hand. An example of one that we built, we essentially just built a set of templates, and you just hand a resource name to it, and boom, here's a bunch of resource files that I can go in and edit. If I want to add a sub-resource, the tool can just handle that by giving it like --sub. While there are tools that are out there like this, you can write them yourself without much work. You probably already, if you were going to go and write something verbose anyways, you're probably doing a lot of cutting and pasting anyways, so that becomes your template. That's all you need to actually go and copy. So once you have these schema files written and Markdown files written, this can be then converted into actual docs. So we run this one shell script that goes through all the files, it validates them, and actually converts them into HTML, puts them in one public folder. This is sort of a breakdown of sort of what's actually happening with these REML files, which you write up. We use a REML. We actually create these REML files from code, and then that code is combined with Markdown files, which are the tutorials, and then we turn that into HTML. The REML, on the other hand, is directly used just for SDKs. There are other elements to just taking, spec files and converting them to HTML. We use a Lefthand Nav, which handles all those tutorial files, and it handles taking the files that we have and turning them into a Lefthand Nav. So you see the JSON file on the left, that becomes what is on the right. This is unthemed. We have another tool that actually themes it all. And what it ends up outputting is something like this. You have the Lefthand Nav on the left, and the Markdown is on the right, and then each resource looks something like that. We take the bodies, all the example code, the spec itself, and actually generate documentation from that to get something so that it's pretty much a complete reference doc with anything that you could want. We first developed this by hand, so we would actually create each of these pages with HTML, and eventually we built these automated tools because that was hard to update, obviously, and a lot of work. So we found a template that worked for us, and then we built the tools to generate that template. Once you have a spec file, it's not that hard to create things like SDKs, depending on the language you choose. There's a lot of pre-built ones out there. Some of them are really good, some of them are really bad. Typically, the ones that are better are ones that were created as its own SDK, and then the internals were pulled out, and then a spec was actually put in. It just makes it feel more like an SDK you would be used to, not something that is really prescriptive. If you want something like a client wrapper with a spec, they're not that hard to create, and those are going to be better in quality. The REML one's pretty good. It just creates JSON, and the Swagger code gen. Some of the SDKs that it generates are pretty good. Other ones of them are just broken. If you look at their issues, you can see which ones are good and which ones aren't. Major takeaways from this is we should be taking our documentation as an actual product. If your API is what people are consuming, if that's what your product is, you need to invest in the tools to actually build the documentation to let people use that. If you never actually think of it like a product, you only think of it like, oh, we'll just write the documentation after, maybe we'll put it in a Google Doc and just share it. it just becomes overhead for you. You won't want to update it. And what that'll lead to is people won't want to use your API. You can actually build the tools to do something like this. I found that Go's CLI is actually really good. It makes it really easy to build these, and also it's easy to share. So if you as a developer aren't the one who's actually updating the documentation, you have maybe a PM or something that is doing it. If you're using Go tools, then you can just share it as a binary. They don't need to know how to use Ruby or Node or anything like that. Yeah, so hopefully you have a better understanding how you should be building your documentation. Any questions? No questions.
Do you think you kind of owe it to your users to build clients for them in all sorts of languages, or do you do
the question was, do you think that you owe it to your clients to build clients in their language for them?
Yeah.
I think that it depends. So if you have, if you're building something where it's going to be complicated for someone to use an existing, like just HTTP, then yeah, you should probably have some sort of client wrapper out there. They're not that hard to make. The problem is that if you don't, from day one, have those tools out, people might choose not to use your tool because someone else has a client for theirs. On the other side, you could build a really bad one. And so if you think you can do it well enough, I would say go for it and do it. We built all of ours, which are very light wrappers, in about 2 weeks. We built like 4 or 5 of them, and they're not that great, but they do enough, and they don't really have any magic in them. But if we hadn't done those, I think people would have been less likely to use our tool. Specifically, like when you're on like a sales call or something like that, and someone's like, "Well, do you have like a Python library?" You can say, "Yes, we do," even if it's not that great. You still get to check that box. Any other questions? Yes.
Do you have any thoughts on creating good API documentation that outlines valid values for certain things that get sent in, especially if those values might be maintained by someone less technical who knows the data better, that says, you can send in these values over here and that's what they mean, or this is what these codes mean that come out, kind of thing.
Yeah, so the question was, do you have any advice for, in summary, in how to give your clients who read, building your docs, giving them parameters that they might not have actually generated themselves? Or like what's valid to pass in?
More like, let's say you say, tell me about this thing in your API call, and it has a couple of description codes that come back and what they mean, but someone else
like
might actually
response codes and understanding.
And not so much of a pass-fail, but more of a, you say A123 means it's a green thing, or B7 means it's.
Gotcha. So how do you describe? What sort of responses would look like, and sort of how those get translated? We normally do them out just as HTML files. It's like here is, we'll include links because most people aren't looking for it in the call itself. So we have other pages that we link to where we describe what those response codes are and what they translate to. However, if there might be a deeper issue if you're returning codes that the person consuming it isn't going to know what they are. And that might be something that you would want to wrap in a client library or something like that, creating it sort of like an object where you can actually give it a description to understand what it is. Yeah. But most of the time we just write states out. We don't automatically generate those because there's Normally there's not that many of them, for us at least. If there's a lot, you might need something else. But just being able to describe those and what they are. Any other questions?
What are some of the biggest failures you've seen designing and building the WePay API? What have you learned from that?
The WePay API specifically, so we, in our current version that people have access to, we have another version that will come out in the next few months. But the version that's out there right now, we've done a lot of what's there is not particularly resource oriented and more surrounds, there's a lot of alias calls. And we've found that we either have people who really love them, or we have people, we have a lot of people who tell us, your API is amazing, it's so easy to use. And then you have other people who try to combine them with other things, and coming from more like a PayPal mindset, it's harder for them to understand. So in our next version, while we're keeping a lot of the alias calls because people like them, there'll be more resource options to call the same things. That's probably like one of the bigger things we've learned from having a lot of people use our own API. So I heard yesterday one of the best API stories, which was apparently if you call the National Weather Services API, it does geolocation on you, regardless of like where your like server is. So if your server has to be sitting in Virginia, they'll give you the weather for Virginia, even if that's not where you are. So that might be the most epic fail of people not understanding how APIs are used. Any other questions?
Have you done requests for which errors can possibly be thrown from which endpoints and documentation for that? And if so, how have you solved that problem?
Could you repeat the question?
So certain endpoints are going to return certain errors sometimes, different from other endpoints. Sort of like in a strongly typed language, you might have a throws blah exception. Have you gotten requests for that in your API? And if so, have you solved that problem and how?
So explaining to a user how certain errors, what errors might be thrown by different endpoints.
That's right.
So we have one document that describes the error states that we might throw. So we try to keep it consistent. That's the first step. Is trying to make sure that when an error gets thrown, it's thrown at least in a consistent way. So if you know how to handle it generally, you'll know what's going on. We run into the problem where there's a lot of errors that that we can throw that we don't actually know what's going on. It's actually a problem with like a user credit card. So like, you know, when you make a call to WePay, we're actually talking to like 4 different banks down the line, and like any error in that flow, it could be a MasterCard or whatever, could be causing the problem. So we try to handle it generally and say, okay, so most people can handle. I think we have like there's like 4 or 5 different like error states that we sort of like combine things down to. And if you get one of those, there's a way to handle it, which is mostly like, you should retry, there's something wrong with the data, or like, we don't know what's going on, you should probably call us. Or like, they should call their bank, one or the other. So I think that's the big thing, is just trying to simplify it down. And if you can't do that, I would just be really explicit in the docs about how to handle things, and perhaps giving someone like a pseudocode like case structure of what they might want to do. Not making me have to come up with the logic myself is going to make me happier. Any other questions? Awesome. Thank you all for coming.